So let's take a look at how we solve these momentum problems. First of all, which is more momentum? Well, momentum is calculated P equals mv, or mass times velocity. For our first situation, we've got a 3 kilogram mass times a velocity of 9 meters per second, which gives us a momentum of 27 kilogram meters per second. Well, in our second situation, we've got a 5 kilogram mass traveling at 5 meters per second. It's going to give us a momentum of 25 kilogram meters per second. So one of the takeaways from this was we had a smaller mass that ended up having a larger momentum, and that was because it was moving at a higher velocity. Remember that momentum is the combination of the mass and the velocity. So if something has a really, really high velocity with a small mass, it can have a lot of momentum. A very good example of that is a bullet. A bullet, which is really, really small, but is traveling really, really fast, can have enough momentum to knock you down, because even though the mass is small, the velocity is high. The momentum of a 25 kilogram cannonball, well, it's going to be the mass, 25 times 100. That's going to be a momentum of 2,500 kilograms meter per second. Now, this time we want to know, well, what's the velocity if we know the momentum? Well, momentum is mv. We've got a momentum of 3. We know that it is 0.5 kilograms. We want to know v. So we divide by 0.5 on both sides. And we get a final velocity of 6 meters per second. So here we've got a boy on a skateboard, and he's riding on the skateboard. We know what's the momentum of the boy's skateboard together if they're going 8 meters per second, 8.5 meters per second. Well, once again, it's the mass times the velocity. But now we've got the mass of the boy and the mass of the skateboard together. So we're talking about 57 kilograms, because they are both moving together as one object. And they are both moving 8.5 meters per second. That will give us a momentum of 484.5 kilograms times meters per second. Now, let's say that boy in the skateboard is going along and his friend hands him a 20 kilogram rock as he skates by. What is his new momentum? Well, remember that momentum is conserved. It's the creator of the story. So he had 484.5 kilogram times meters per second worth of momentum. He still has that much momentum. Nothing has changed. There was no other force. There was nothing else that changed his velocity. He just now has more mass. So we want to know, well, what is the new velocity? His momentum is still this much kilograms. Well, what's the mass now? Well, he was 57 before, but now he's also carrying a 20 kilogram rock. So now we're up to 77 kilograms velocity. Divided by 77 on both sides, and we'll get a new velocity of 6.3 meters per second. So now his velocity is a little bit lower. And that makes sense, because now that he has more mass, his velocity is going to be lower in order to have the same momentum. because momentum is conserved. He had the same momentum that he started with. So now we've got a 75 kilogram running back, and that running back's moving at 5 meters per second. We've got a smaller tackler, only 60 kilogram, wants to stop the running back's momentum. Sports is a big study in momentum. So we've got the ball carrier going this way, and we've got a tackler coming this way. And basically what we want to have is a net momentum of 0. We want to stop the ball carrier, the running back's forward momentum. We basically want to make their velocity 0. Well, what is their momentum? What's their mass? 75 times 5. So the ball carrier has a momentum of 375. In order for his momentum to go to 0, the tackler must have a momentum of 375 going in the opposite direction. Because remember, momentum's a vector, so you're going to have positive and negative. We'll go ahead and call this one the positive, the negative, if we said the other one was positive. And they will cancel each other out, and the net momentum of them together will be 0. They will be at 0 velocity. They'll be stopped. So, how much momentum does this person have to have? Got to have 375 negative. We know their mass is 60. What would their velocity have to be in order to get that much momentum that would match the ball carrier? The tackler's velocity would have to be negative 6.25 meters per second. Now you'll notice the running back was going 5, was going slower. So the tackler has to run faster because they have less mass in order to have an equal momentum to the running back. So we've got a toy freight train, and it's moving at 5 meters per second, and it collides with a stationary empty car. Now, at the collision, they stick together like train cars do. It's called coupling. What's the final velocity of the pair? Remember, momentum is conserved. So momentum before equals momentum after. So let's do the before part. Okay. The train, momentum is its mass times its velocity. It has a mass of 50. It has a velocity of 5. So its momentum is 250. Now, the car has an initial momentum of 0 because it's not moving. Okay, now the after. The total momentum before was 250. That means the total momentum after is also 250. What's the mass? Well, now we've got 50 kilograms and 15 kilograms moving together, so that's a mass of 65. The velocity is 250 divided by 65, which equals 3.8. 3.8 meters per second. One of the tricks with these problems, you always have to remember that momentum is conserved. So before and after, the momentums are going to be equal.